Aaron, stop
The
hitting me.
distributive property is up there on the board. This is something you've seen, distributive property. The root word of distributive is distribute. And so if you notice here, this is taken from your book, it says A times the quantity B plus C. What you're going to do with that A is you're going to distribute it to both the B and the C term. Now what we do then is we multiply A times B plus A times C. Notice the A can also come at the end, in which case you would distribute it that way. You distribute it both to the B and the C. You can also do this with subtraction. It's the exact same steps. And then you can go after with subtraction. So notice what they've done here. They've taken 3 times 2 plus 5. We already know that that's 3 times 7, which is 21. They're showing you how that works. Okay? You're taking 3 times 2, and then you're adding 3 times 5. 3 times 2 is 6, 3 times 5 is 15. You get the 21 to work. Now obviously the easiest way is the left way, the left part of the equation. Okay, but they're showing you how that all works and how everything is justified. So now what we're going to do is we're going to look at a problem very similar to that. We're going to rewrite 7 times 49. Okay. So I'm going to think, okay, 7 times 49 is really close to 7 times 50, right? Isn't that close? So it's really close to 50, and so I'm going to think, what do I do to 50 to get 49? I subtract 1, right? So I could write it that way. Would you agree that's the same thing? I could have actually, if I wanted to, I could have done this as well. I could have done 40 plus 9. That's the same thing. 49 is 40 plus 9. So basically I took the biggest number, not the 7, but the 49, and I figured out a way to write that. So I either wrote it as 50 minus 1 or 40 plus 9. And now what they want you to do is they want you to just distribute that. So I'm going to distribute that here. So I'm going to take 7 times 50, and then I'm going to bring down my minus sign, and then 7 times 1. So what is 7 times 50? 350. Okay, for those of you wondering, how do you get that? You take your 7 times 5 and then add a 0. What's 7 times 1? 7. So you get 343. Okay, that's one way. If I did it this way, I'm just going to take 7 times 40, which is 280, plus 7 times 9, which is 63. And I get the same thing. So you don't necessarily have to do it exactly the same as somebody else. Let's look at another one of those. 304 times 15. So what's the biggest number? 304. So we have to figure out a way to write 304. What would be a way to write 304? 300 plus 4. Now I would probably go that way. Another way I could write that would be 310 minus what? 6. I'm going to take that times 15. Okay. So what do you do now? Yep, multiply. So I'm going to distribute. So 300 times 15. Yep, plus 4 times 15. So you have 4,500 plus 60. So your answer is 4,560. Think you can handle that? That's going to be the first part of your assignment. Basically start with the biggest number, rewrite that using 2 different numbers. Let's look at the next part. Rewrite each expression using the distributive property, then simplify. So what I'm going to do here with the 7 is I'm going to distribute it to each. So I'm going to take 7 times 3w minus 7 times 5. Now, a lot of you probably won't need to write out this step in purple. You can just jump right to the answer. I'm just writing this out since it's the first time we've looked at that. But what's 7 times 3w? 21w. Remember, we just take 7 times 3 and then add our w. What is 7 times 5? 35. Can you combine those at all? No. There's your answer. Now the next one is the exact same thing, except for our 4 is written after. But I'm still going to do it the exact same way. So let's try and do it instead of writing that intermediate step. So I'm going to take 4 times 6v squared. What's that going to be? 24v squared. I'm going to take 4 times v. What's that going to give me? 4v. I'm going to take 4 times negative 3. What's that going to give me? Negative 12. Can you combine anything there? Nope.
Could it be v minus 3?
When you say v minus 3, what do you mean v minus 3?
Is it 6v squared plus v minus 3?
Yeah. But this is treated as a negative 3 because subtraction means that we add the opposite, so I can put it this way, in which case it's still 4 times negative 3. So what you could do then is answer like this as well. It's the same thing. You're going to get a negative 12. Yes, sir?
What do you mean by like combining?
We'll see in the next one because I bet you we'll be able to shortly. Okay, so. All right, let's distribute our negative 3 here. Okay, if I distribute my negative 3, what do I get?
Negative 6.
Negative 6. Negative 3 times negative 5q.
15.
Positive 15q. Very good. Nice job. All right, I want you to do this last one real quick in your notes here. Negative 4 times negative 8 minus 3m. Just grab a sheet of scratch paper real quick. Just jot down how you would do that. Time for you to get involved. Okay, so first things first. Negative 4 times negative 8.
32.
32. Remember, negative negative is a positive. Now I have negative 4 times, this is a negative 3. So negative 4 times negative 3 is 12m. Positive 12m. So, nice job from what I saw when I went around. Now this one says simplify each expression if not possible. You write simplified. So when I say to simplify each expression, that means to combine what's known as like terms. So if I look here, I've got a 6n and a 4n. Those are like terms. Like terms mean all variables are exactly the same. All powers are exactly the same with the variables. So the n's are exactly the same. I take 6n and I minus 4n. The net result is 2n. Okay? So there you go, 2n. There's your answer. All right, let's look at the next one. Like terms, do I see anything that's like?
B and D.
I have a b squared here. Do I have another b squared somewhere in the problem? No. I have a 13b. Is there another b somewhere in the problem?
Yes.
Now remember what I said. Exponents have to be identical. So b squared, there has to be another b squared. B, there has to be another b. And then is there another 13?
No.
Or another number? Another constant?
Yeah.
No, there's not. It has to be exactly the same. The only way I could add 13 to something is if it would be like plus 5. Or if it would be like minus 6. Has to be the exact same in terms of variables and numbers. So in this case, this one is actually simplified. We got a couple more we're going to look at. So let's look at this next one. 4y cubed. Is there another y cubed somewhere? No. Let's look at the y's. Is there another y?
Yes.
Yeah, so these two right here are what we call like terms. We're going to combine those. I have 2y and I have negative 8y. If you combine those, you get negative 6y. What do I do with the 4y cubed and the 5? I leave them the exact same and I bring them down. Let's look at the next one. I have a 7a. Is there another like term with 7a?
Yes.
Which one?
2a.
So I got 7a, negative 2a. 7a and negative 2a is
5a.
5a. What about 4? Do I have another like term with 4? Nope, so I put plus 4. What about the negative 6a squared?
No.
Nope, so I just leave it as it is. Okay, questions on the like terms? Your assignment for Tuesday then is the following. I do have a quiz which I'm going to give to you, and then you have the remainder of time to work. So, for Tuesday, there you go.